Today we shall deal about reflection of waves. What is reflection of waves and what is reflection of waves? We shall try to explain in sound waves. An everyday example of the reflection of sound waves from a rigid boundary is the phenomenon of echo. If the boundary is not completely rigid or it's an interface between two different elastic media, the effect of boundary conditions on an incident pulse or a wave is somewhat complicated. A part of the wave is reflected and a part is transmitted into the second medium. If a wave is incident obliquely on the boundary between the two different media, the transmitted wave is called the reflected wave. The incident and refracted waves obey Snell's law of reflection, and the reflected waves obey the usual law of reflection, as shown in the figure A and B. A pulse incident from the right is reflected at the left end of the string, which is tied to a ball. Note that the reflected pulse is inverted from the incident pulse. Here the left end is tied to a ring that can slide up and down without friction on the rod. Now the reflected pulse is not inverted by reflection. A traveling wave at a rigid boundary or a closed yield is reflected with a phase reversal, but the reflection at an open boundary takes place in a phase change. Let the incident wave be represented by bravura S and x minus omega t. Then for reflection at a rigid boundary, the reflected wave is represented by bravura S and x plus omega t plus pi, bravura minus S and x plus omega t. For reflection at an open boundary, the reflected wave is represented by bravura S and x plus omega t. Thus, the mathematical function expression for reflection wave is bravura S and kx plus omega t.